Okay, so picking up where we left off on the last video, I'm going to solve for x in this problem. So this is a log base 4, and these are logs base 4. So if I could get these put together, I could say that this equals whatever that is. So that's what I'm going to try to do. So I've got log 4 of 3x plus 2 that I'm just going to leave alone for a minute. And then the rule on this one, these are being added. So if I want to kind of compress those back together, that is multiplication. So this is 7 times 3. All right, so that tells me that this equals this. So 3x plus 2 equals 21, because 7 times 3 is 21. So if I minus 2, I get 3x equals 19. So x equals 19 thirds. I would just be lazy and keep it at that. I would check, plug this back in up here and make sure that you have logs that are greater than 0, the log of something greater than 0. This one does work out. The only place I can plug that in is right here. So if I put 19 over 3 here, those 3's cancel. I get 19 plus 2, which is 21. So that works. Okay, so this is my answer for that one. All right, number 2. This one, I would get these back as exponents. So this one ends up log base 2 of x cubed equals log base 2 of 3 squared. So then again, I can set these equal to each other. X cubed equals 3 squared, which I'm just going to write as 9. So then x equals the cube root of 9. Again, I would plug that back up there, make sure you get things that are greater than 0, and we do in that case. Okay, this one, to kind of get this put together, remember subtraction means I have a log with division. So log of x plus 2 over x equals, I'm going to bring this exponent up, so log of 4 squared. Remember, these are base 10s. So that means I have x plus 2 over x equals 16, because 4 squared is 16. Multiply both sides by x. That gives me x plus 2 equals 16x. And then if I subtract my x from each side, that gives me 2 equals 15x. So 2/15 equals x. Again, if I plug this in up here, make sure I get all positives, which I do. Okay, number 4. This one, I would use this rule again. If they're adding, that's multiplication if I combine those. So natural log of x times x plus 6 equals the natural log of 9 to the 1/2 power, which means the square root of 9. So, and remember, it's only going to be a positive situation there. So this, if I distribute, I get x squared plus 6x equals 3. So I went ahead and took my natural logs away and simplified those at the same time. Then, because I have a quadratic this time, I'm going to get everything over to one side, set it equal to 0. I wish this would factor, but it won't, so I'm going to use quadratic formula. So x equals -6 plus or minus the square root of 6 squared minus 4 times 1 times -3 all over 2a, or 2 times 1. Okay, so that ends up giving me a -6 plus or minus the square root of, this would be 36 plus 12, so 48 over 2. Just to avoid using a calculator, I'm going to simplify this. So 48 will break down to 16 times 3. So 16 times 3 means 4 square root 3. So this is -6 plus or minus 4 square root 3 all over 2, and then I can simplify by dividing by 2. So that gives me a negative 3 plus or minus 2 square root 3. So I have two answers here. I want you to be careful with that. So one answer is negative 3 plus 2 square root 3. The other one is negative 3 minus 2 square root 3. This one is definitely a negative. If I take a negative 3 and I subtract 2 square root 3 more, I'm going to end up in the negatives. So this natural log of that is going to be negative. So that tells me that one is an extraneous solution. That does not work. So this one is extraneous. And you don't have to label that. Just know that that's not an answer. This one, if I take negative 3 and I add a 2 square root 3, you can check that on a calculator if you want, but that does end up positive. So this one is okay. That's your solution. Okay, this one, again, I've got addition, so I'm going to use multiplication here for these. So I have a log base 6 of x times x plus 5. I guess you could kind of write it like that, equals 2. So I'm going to distribute that out. Actually, okay, wait. So I have a log base 6 still. I didn't get rid of that, and I don't have a log base 6 over here. So I need to think about my rules again. So remember, your base is still your base. So this base of 6 and this exponent squared equals this. So I'm going to call that x squared plus 5x. I'm going to go ahead and distribute that out. So that means 36 equals x squared plus 5x. If I want it to be equal to 0, like I did on this one, that gives me x squared plus 5x minus 36. And then that one will factor. So let's do that. That's way easier than quadratic formula. So x and x, that would be a 9 and a 4. A positive 9 minus a 4 would give me a 5 in the middle. So that means x equals negative 9 and x equals 4. But again, go back up and check them. If I put a negative 9 right here, that's going to give me a negative 4. Same thing here. That's going to give me a negative 9. So this one is extraneous, if I can spell extraneous. And then if I put 4 in there, that one actually works. So that one's okay. Okay, so then let's look at just a few more of those types because they keep getting kind of more and more complicated. This one, actually this one is really similar to that last one. So I'm not going to worry about doing that one. If you need more examples though, like number 5, let me know. I'm going to skip down to number 7 here. So I have a log of x plus 4 equals 2 minus log of x minus 2. So I'm going to get my logs together on one side. So I have a log of x plus 4 plus, if I add this to both sides, a log of x minus 2, and that equals 2. Then I can put these together with multiplication. So this would be a log of x plus 4 times x minus 2 equals 2. And then I'm going to rewrite that again using my rules. So again, this one's a base 10. So I have a base of 10 with an exponent of 2 equals this. So I'll go ahead and write it out like this for now. And then let's multiply that out. So 100 equals x squared. This would be a minus 2x plus a 4x, so that's plus 2x minus 8. Again, though, I want to get everything to one side, so 0 equals x squared plus 2x minus 108. And I'm going to have to use quadratic formula on that one again. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so this one ends up a negative 2 plus or minus the square root. If I use my calculator, I end up with the square root of 4 36. Okay, and then this breaks down and gives me, if you do 4 times 109, that works. So this is going to be -2 plus or minus 2 square root of 109 all over 2. So I'm going to rewrite this then as I have two answers. I have -1 plus 1 square root of 109, or just square root of 109. And then I have -1 minus square root of 109. So that's me just simplifying those. This one again is definitely a negative. So when I go to plug that in, if I have a negative right here minus another 2, that's negative. So this one is extraneous. This one works. If I plug it in, it works out. And again, you can use your calculator to get that as a decimal or to approximate it. Okay. This one, again, let's see. I'm going to get this one over here to this side. Okay, and then use division to write that out. So I have a log of 57x over x minus 2 equals 2. Okay, and then I'm going to use my rules again. So I have a base 10 squared equals that 57x over x minus 2. Well, that means I have 100. And I'm going to go ahead and multiply both sides by x minus 2. So that equals 57x. So 100x minus 200 equals 57x. I would get everything that's like terms together. So I'm going to minus this 100x. So -200 equals, that would be 57 minus 100. That'd be -43. So that gives me 200 over 43 equals x. Again, if I plug this in up here, 200 over 43 minus 2 is definitely going to be positive. Same thing here, that's going to be positive. So that one is fine. Okay. Let's do one more of these, and then I will stop the torture. So number 9 is asking me, so I've got a natural log of x plus a 1, or equals 1 plus a natural log of x minus, or x plus 1. So I'm going to move this over again so that I get them on the same side. So natural log of x minus natural log of x plus 1 equals 1. And then that's division right there. So I have the natural log of x over x plus 1 equals 1. Now this is where I have to use my rules again. So natural log means I'm going to do e to the first power equals this, x over x plus 1. So that's those rules again. Just keep going back to those rules. The more you use them, the better you get at them. So that means I have e times x plus 1 equals x. So I'm going to distribute that. So ex plus e equals x, which is really weird. I'm going to get my x's together and my e's together. So I'm going to minus my ex over here. So e equals x minus ex. And then let's factor out this x. So my whole point was to get x by itself. Remember that. So up here, when I'm seeing this x and this x, I'm thinking I got to get that out of there and then get it together. So that gives me e equals x times 1 minus e. Then I can divide by that. So e over 1 minus e equals x, which is really weird. And if you approximate that on a calculator, so I would plug this in. Remember, we have to plug it back in up here and make sure we get a positive value for those. Well, if you approximate this on a calculator, x is about -1.58. So after all that lovely work, this actually does not work up here. It gives me an extraneous solution. So that one is a no solution because there's no other option. Okay, so that's the last one for now. And then the other 2 we have to worry about is graphing, so I'll cover those next.